Greetings to all. Today, we, the student of Mega Institute of Engineering and Technology for Women, Department of Computer Science Engineering. Our project is on smart blind stick for visually impaired people to detect obstacle using ultrasonic sensor. Our team named the Achievers. Team members D. Akamsha, Priyanka, K. Prasanna, and Makila P. Supriya. I am Akamsha. So let us go to our project. Following contents are abstract, motivation, methodology, block diagram with description, software required, result, output, pick of the project model. First, let us go with abstract. The major sensory organ of a person is their eyes. Being blind in this world, it is a multiple normal mishaps can be happen. Presently, people are using blind stick as their tool for directing themselves. But in our project, we will develop a tool which can be served as a blind stick and being more helpful than a conventional one. The smart blind stick for the blind, as name suggested, it is a device for visually impaired people. It will guide the user to reach their destination without colliding with the obstacle. That is by using an ultrasonic sensor and water sensor in the blind stick. Here, the instrument stands to use to perceive the obstacles at range of 100 meters and water sensor which makes sure to avoid any water puddles on the way. It has even an inbuilt buzzer and vibration motor through which one can know when any obstacle is detected. Now let us go to the motivation. Here, globally, 1.1 billion people were living with a vision loss in 2020 and 43 million people are blind. 295 million people have MSVI and the rest have a mild vision impairment. India has around 12 million visually impaired people due to the many reasons. One of the main reason it can be diabetic and which makes India home to 1/3 of world's blind population. Hence, our project come as a proposed solution to enable visually impaired people to detect obstacles and dangers in front of them during walking and to identify the world around. Here, the system is designed to act like an artificial vision and alarm unit. Now I over to Priyanka.
Priyanka, I'm going to explain block diagram. This block diagram mainly consists of power supply, Arduino microcontroller, ultrasonic sensor, water sensor, buzzer, and vibrating motor. And now coming to block diagram description. Power supply. First one is power supply. Coming to power supply, initially 9 volts power supply is provided to the Arduino board, which is further connected to all the input devices. Then the entire system is commanded only using through this Arduino controller. And the next one is ultrasonic sensor. Sensor detects the obstacles at a distance of 100 centimeters from the target object. Whenever an obstacle is detected, the ultrasonic sensor passes an alert to the microcontroller. And the next one is water sensor. Water sensor is nothing but whenever the water detects with the help of water sensor, it passes the alert of water to the Arduino microcontroller. Coming to buzzer, the Arduino microcontroller will give an alert with the help of buzzer, which generates the sound. And the last one is vibrating motor. The Arduino microcontroller will give an alert through vibrations generated by the vibrating motor. This is all about the block diagram and description. And now over to Akila.
Hi, this is Akila. I am going to explain about software required. The Arduino Integrated Development Environment or Arduino software IDE is an open source software which is used to write and dump codes into Arduino boards by interfacing it through a computer. The main parts and features of this software it contains a text editor for writing code and message area, a text console, a toolbar with buttons for common functions. So basically, when you launch the Arduino IDE text editor, it has many word processing features such as a copy paste. As you can see, there you're gonna be fineness and the program that is being used to write the IDE are called sketches. Coming to the next slide, these sketches are written in the text editor and are saved with the file extension. Look at the picture, we find this default code as you can see, and this default code has two key functions. It has this startup function and it has the loop function. Startup function. So basically the startup function, this is where we write, and when we power on the Arduino, the very first place it released would be the setup. So it read the setup function once and it will never read the setup function again unless it comes to the loop. And in the loop function, this where we include the key or the mean code for they are doing what we want to Arduino to do if we wanted to turn on an IDE. That codes are here, and then it's going to loop, it's going to read, and brief start from top and bottom when it ends. The IDE applications is suitable for different operating systems such as Windows, Linux, and Mac OS X, and it supports programming languages such as C and C++. But in our project, we use C program. Following program. First, connect trigger pin of ultrasonic to 10 pin of Arduino. Next, connect echo pin of ultrasonic to Arduino digital pin 10. Connect positive terminal of buzzer with Arduino digital pin 7. And again connect signal output pin of water sensor to Arduino digital pin 12. And connect positive pin of water sensor to Arduino digital pin 13. Void setup. And again trigger pin output, echo pin input, buzzer out, echo pin input, water sensor input, buzzer output, vibrator output, and then void loop. Coming to the void loop, trigger pin low and then delay microsecond 2, trigger pin high, then delay microseconds 10, echo pin high, and calculate the distance. After, if a water sensor output is low, means no water, and check the distance, vibrate, and then the vibrator goes low. Slide. And then after that vibrator is high. It means if water sensor output is high, means water is present. So finally we start measuring the distance from any obstacle. There will be no alarm if the measured distance is more than 100 centimeter. But it is less than 100 centimeter, the alarm will start by beeping the buzzer. So this is all about software required. Now I over to Prasanna.
This is Prasanna. I am going to explain about result and output of this project. This project proposed the design and architecture of smart electronic guiding stick for blind people. It helps the visually impaired people to walk more confidently. Now, we discuss about some advantages of this project. First of all, it is effective and it requires less cost. And it is very effective detection of obstacles and water puddles. It is easy to handle and it's lightweight. Now over to Priyanka.
This is Priyanka. Coming to the project model, this is the picture of project model. And coming to conclusion, the smart stick acts as a basic platform for the coming generation of more aiding devices to help the visually impaired to be more safe. It is effective and effort. It leads to good results in detecting the obstacles lying ahead of the user in a range of 4 meters, detecting straits and water pits. And our main motto is to help the visually impaired people by using advanced technology. Thanking you.